Hi everyone. Today we are going to discuss about the analysis method. First method is called nodal analysis method, where the next method is called mesh analysis, or this mesh is also called as a loop analysis. Let's first try to understand how to apply it, and later let's try to identify for a given network either nodal analysis has to be applied or mesh analysis has to be applied, which is best. Okay, so let's try to understand about nodal analysis. So nodal analysis is a part of analysis. This is used to find a branch current. For example, a resistor is there of R ohms. If you want to find out the current across R ohm, then we can use nodal analysis. The purpose of nodal analysis is to find the current in a given resistive branch. So here this nodal analysis is performed by applying Kirchhoff's current law. This is the second point what you have to remember. So here while solving you have to assume the node. For example, you have some voltage source of 10 volts, and here we are going to apply the nodal analysis. So we have to assume this node is of a higher potential. Okay, so here you have some resistive branch. If you take, so let us mark this is an unknown node. You have to assume that this node is of a higher potential than compared to any other node in the network. For example, this may be 50 ohms or this may be 10 ohms. Our assumption is this node is of a higher potential and these nodes are of a lower potential. Then current flows from high potential to low potential. Current flows from high potential to low potential. We have to write down the KVL expression and have to express them. So this is the concept of nodal analysis. The similar concept is also mesh analysis. Mesh means if you have a closed path between the branches. This is the closed path between the branches. So applying this mesh analysis also will give the current across the branch R1 or the current across the branch R2. The current across the branch R1, R2, the current is same. This is called mesh analysis. Here also you are going to find out the current I1 or the current I or the network shown. So this mesh is like an loop. That's why this analysis is also called as a loop analysis. Now let's try to understand which analysis has to be applied for which type of network. We'll verify with an problem, and to identify how many number of nodes are there, the formula is number of nodes is equal to number of junctions minus 1. Similarly, to identify the number of loops, to identify the number of loops, we have the formula is equal to number of branches minus junction minus 1. Okay, so if you apply this formula, then we can identify the number of loops. By applying this formula, we can find out the number of nodes. This is how to identify the number of nodes and the number of nodes. Now we need to know about what is meant by a node and what is meant by an junction. What is the difference between a node and an junction? And we need to understand about what is meant by an branch and what is meant by an circuit element. So in order to understand it, let's try to solve one problem on this analysis. Okay, so before going to this, let's try to understand a few concepts. First one is what is meant by an node. Second one is what is meant by an junction, and third one what is meant by an branch. So node is nothing but it is an equipotential point between two circuit elements. For example, you have one node here, so you have a resistor here. So this will act as an, this joining point is called as an node. When two elements are joined, this also will act as an node, and this is as node 1, this is node 2. So actually this we have to consider what is the voltage is available. For example, V equal to 5 volts. The voltage at this point is 5 volts and the voltage at this point is 0 volts, and this will act as an node. So node is nothing but it is a point at which two circuit elements are joined. So if two resistives or two circuit elements are joined, then this is called as an node. Then what is meant by an junction? In the same network, in the same network, you have this one. So this is nothing but node. This is nothing but junction. Sir, how to differentiate a junction? So junction is a point where three or more elements are joined. So this is element 1, this is element 2, this is element 3. So three elements are joined, or three circuit elements are joined, then it is called as an junction. So technical also you know what is meant by an junction. Junction is nothing but you have one entry point and two exit point. You can take railway junctions. So railway junction, for example, if you take this Gudur junction, so Gudur junction, the incoming line is from, if you take this Gudur junction, why it is called junction? So we have the input from Vijayawada, one will go directly go to, one will directly go to Chennai and one will directly go to Tirupati. You have one entry and two exits or two outputs. So then this is called as an junction. Here this is called as node and this is called as an junction. Remember, this junction may be also called as node, but this node is not called as a junction. So this node is not an junction, but this junction point is a junction and as well as an node. That's how to understand a node and then junction. So between two, for example, between branch is nothing but the elements which lies between two junction points. This is an element which lie between two junction points. This lies between two junction points. So that is called the difference between a node. So this is node 1, this is node 2, this is called node. Junction means if three circuit elements R1, R2, R3, R3, R4 circuit elements are joined at a place, then it's called as an junction. Branch means, so between an element existing between two junction points is called as an branch. Let's try to solve a problem so you can understand better. So the problem asked is, a network is shown below. Identify the number of circuit elements is the first question asked. Second one, identify the number of nodes. Third one, identify the number of junction points. Fourth question asked is identify the number of branches. Fifth question asked is identify the number of nodes and identify the number of meshes is the question given to us. So the network given to us is like this. So you have an voltage source, you have R1, this is the network given to us. This is with EMF E1, The resistance value is R1, the resistance value is R2, and this resistance value is R3, and this here you have one more resistor, this is R4, and here we have R5, here we have R6, here we have R7, here we have R8, and here we have R9. So these are the things given to us. Let's try to identify step by step everyone. Okay, first one, identify the circuit elements. So in the given problem, you have to identify the number of circuit elements. So it's very simple to understand. So E is one circuit elements plus how many resistors are there? R1, R2, R3, R4, R5, R6, R7, R8, R9 plus 9. Okay, varying from R1 to R9. So 9 plus 1, how many circuit elements are there? Totally 10 circuit elements, including one voltage source. This is about 9 resistors and 1 voltage source. Next we want to identify the number of nodes. Okay, so identify the number of nodes. So coming to the circuit, so in this is node 1, I am labeling this as node A, and this is node B, this is node C, this is node D, this is node E, this is node F, this is node G. Okay, so how many nodes are there? G, and this is one more node. Okay, so as per this, let's try to identify the number of nodes. So how many nodes are there? A node, B node, C node, D node, E node, F node, G node, and H node. So 1 2 3 4 5 6 7 8. Okay, so totally we are going to have totally 8 nodes. We are going to have 8 nodes in the given network. So try to understand junction points. How many junction points are there? You see this node, this is a node connecting these two elements, this is a node connecting three elements, this is a node connecting two elements, this is a node which is connecting three elements, this is a node. Now we want to identify the junction points which connect more than three circuit elements, more than three circuit elements. So how to identify the junction points? So coming to here, so here we are going to have 1 2 3. This will act as a one junction point, and 1 2 3, this will act as an another junction point. This is one junction point, this is another junction point, and this is another junction point. This is not a junction point. Okay, and this is another junction point. Okay, so how many junction points are there means, so B is a junction point which is linking 1 2 3. Next one, next junction point is B is completed, next junction point is at B, and next one is D. So this is one more junction point. Next one is joining three elements. This is one more junction point, and this is next junction point. So you are going to have B, D, F, G. So total number of junction points are 4. So in all these 4 junction points are again called as nodes. Already I told a junction point can be called as nodes, but a node is never an junction point. So you have 8 nodes. In these 8 nodes, only 4 are junction points. So that is what the concept. And now by seeing the diagram itself, we need to identify the next one. So identify the number of branches. So identify the number of junction points is completed. Identify the number of branches. So branches is between these are the elements or the resistive branches exist between two junction points, between two junction points. So what are the junction points going to have? Let us try to see here. So first junction point, okay. So we're going to have the first junction point. So this is B. So here we are going to have first one is R2 is the one junction point. This is one junction point. Okay. Next one is between these two. Okay. So red colored mark are only junction point. This is one junction point. This is another junction point, which is nothing but R5 plus R6. Next junction point is directly third one, which is nothing but R7 is another branch between two junction points. Next one you have here, so which is nothing but R3. So this is also one fourth branch. Next one between this is one junction point, this is one junction point, this is another junction point, which is nothing but sum of R8 plus R9. This one more junction point, and the next junction point, so this is one junction point, this is one junction point, which will also constitute one more path, so which is nothing but R1 plus R4. So this is R1 plus R4. So totally you are having 1, 2, 3, 4, 5, 6. Therefore, the number of branches for the given network is 6. So you can see them one by one. So this is R2. Next one R5 plus R6 is the second one. Next one R7 is the third one. Next one R3 is the fourth one, and R 8 plus R9 is the fifth one, and this is sixth one. So all these six are called as branches. So now by seeing the circuit only you can see here, so this is one closed path, this is a first closed path, this is second closed path, this is third closed path. So here going to have the number of meshes directly by seeing a number of loops is equal to 3. Let's try to verify with the formula. So what is the formula for number of meshes? Number of meshes or loops is equal to branches minus j minus 1. How many branches are there? 6 minus how many junctions are there? Into have 4 junctions, 4 minus 1. So 6 minus 3 is equal to 3. So directly by physically seeing also, I am directly saying that how many meshes are there in the given network. So this is mesh 1. So this will constitute mesh 1. This will constitute mesh 2. This will constitute mesh 3. So how many meshes are there? 3 meshes are there. How many nodes are there? Already you know that you have 8 nodes. Okay. So how to identify the number of nodes? So the number of unknown nodes is nothing but junctions minus 1. How many junction points are there? 4 minus 1. How many nodes are there? 3 nodes. Okay. So here you have 3 nodes to find out 1, 2, 3. Okay. So that is about all about the identifying the number of elements. Let's try to revise the components very simply. So what is meant by node? The joining of two elements is called as a node. What is meant by junction? So more than 3 elements are joined, then it is called as a junction. What is meant by branch? The elements which lie between two junction points is called as a junction. So we had already understand in this given network how many elements are there. So one voltage source and 9 elements are there, 10 elements are there, 10 circuit elements are there. How many nodes are there? As per we have installed, how many nodes are there? A to H. We are going to have 8 nodes. In this red color marked are nothing but the junction points. How many junction points are there? 4 junction points. How many branches are there which are linking each other? Already we identified 6 branches are there. This is how to identify the number of circuit elements, number of nodes, number of junction points, number of branches, and number of meshes. Now let us try to solve some problem on nodal analysis. So using the question given is using nodal equations, find the current through R2. So it's asking us find the current through R2 branch. So the network given to us is like this. I'm going to have 20 volts. I'm going to have 30 ohm. Here you are going to have 120 ohm. Here you are going to have 100 ohm. Here you are going to have 20 ohm, and here you are going to have 50 volts. So we need to find out the current across R2. This is nothing but R2. Here we need to find the current. So you can see this network. It's very simple to understand. So what is the voltage at this point? This is plus 50 volts, and this is of 0 volts. What is the voltage at this point? It's already clear. This is 20 volts, this is 0 volts. Now here only we have to find out the nodal analysis. So these two are at one point. I can label this node as Vx. Same, this node is also Vx. Now how to apply it? Already we told that assume this voltage is of higher potential. So I am marking with highest potential as Vx. So Vx is connected between these two terminals. Same Vx is also connected between same two terminals. Therefore only one unknown voltage we are going to know. So already I told that assume that this node is of higher potential. Therefore current will flows from high potential to low potential. Mark this current as some I1, and mark this current as some I2, and the current doesn't flows between. Why? Because these all are same. Next one, coming to this branch, and current will flow from high potential to low potential. The current is flowing from high potential to low potential. This will act as I3. The current in this branch will act as I4. Now see this problem and apply the analysis. So apply Kirchhoff's current law at node Vx. Apply KVL at node Vx. At this node you have to apply. At this node, how many currents are entering? So is there any entering current? No. How many currents are leaving? So I1 is the one leaving current, and I2 is the another leaving current. This is what we need to find out. And next one is I3 is the another leaving current. Next one is I4 is the another leaving current. So I can write down 0 is equal to. So how to write down this branch current I1? So I already told current is, this is positive polarity. Current is leaving. What is the leaving polarity of the voltage? So plus Vx, and this is how much potential? This is of minus 50. Current is leaving. What is the leaving polarity you are having? Minus. Okay, so here you have minus. What is the leaving polarity? Minus 50, and minus 0 divided by I can write down the formula for current I equal to V by R. So you can write down high potential minus low potential by R. So high potential is plus Vx, and current is traveling like this, and current is leaving. What is the leaving polarity of this voltage? Minus 50 divided by R. What is the value of R? Is given in the problem as 20 ohms. Plus, sir, how to write down I2 current? I want to write down the current in this branch. I2, already told current flows from high potential to low potential. So the current is leaving. What is the polarity of the voltage? Plus Vx. So high potential, and what is this potential? 0 volt. High potential minus low potential by R. What is the value of R? 100. Plus, how to write down the current I3? So I want to write down the current I3. So current is leaving. Whenever the current is leaving, what is the polarity of the voltage? Plus. So Vx, and current is leaving the source like this, and what is the polarity of this? Minus. Okay, so minus, what is the polarity? Minus, what is the potential? 20 volts divided by R. What is the resistance of this branch? 30 ohm. Coming to the next branch, the branch I4, the current is flowing in this direction. Okay, so whenever the current is flowing, or the leaving polarity of the current, plus, so plus Vx minus 0 divided by R. What is the value of R? 120. So when you separate these terms, and if you write down, so we can write down this as Vx. You take Vx terms as common. So if you take Vx as common, this is 1 by 20 plus 1 by 100 plus 1 by 30 plus 1 by 20. Okay. So minus of 50 by 20 minus 20 by 30. If you solve it, then you are going to get the unknown voltage by using your calculator. Vx is 31.18 volts. Okay, so as per the problem, so here we have 50 volts, here you have got 31.18 volts. I can say it is less than around 20 volts is a drop created in this branch. So the answer may be 100% correct. So now we need to find out, already I told, we need the current I2. How to write down the current I2? Current I2 is equal to Vx minus 0 divided by R is how much? 100. What is the Vx calculated? 31.18 by 100. So the current is 0.31 amperes. So this is how we are solving this problem. Now let us try to solve one more problem of the same category. So here the network given to us is like this. A 2 ohm. So the problem asked is find the current in 1 ohm resistor. Okay. So a 2 ohm resistor, the voltage source is given to us, and a 1 ohm resistor and a 2 ohm resistor and a one more resistor parallel to an current source is given like this. The entering current is 2 amperes. This is of 2 ohms. This is of also 2 ohms. This is of 1 ohm. This is of 2 ohm. This is of 5 volts. So he is asking us to find the current in this branch. I is asking. So already this is very clear that how to apply the nodal analysis. Okay, so you can translate this into two forms. Directly we can apply this. Okay. So what are the values you are going to get? Here is you are going to get this is voltage source V1 and this is a unknown voltage source V2. Already 5 volts is there, and since resistor is there, this will act as an one more new voltage source, and for these two you are going to get. So you can see here we can eliminate this node by performing source transformation. I am redrawing it the node V2. So automatically I am going to get and series resistor with 2 ohm, and I am going to get a voltage source. Okay. So V equal to I into R. What is the current given in the problem? 2 into 2. So the voltage at this point is 4 volts, and the voltage at this point is 2, and redraw the given network. So we need to find out the current in this branch. You see here already we converted this into voltage. There's no need to find out V2. Just we want to find out only V1. If you find V1, automatically you can find the current I. Actually our intention is to find the current I. So how to find current I? I is equal to V1 minus 0 by 1. So if you find out the value of V1, automatically this will be the value of the current. So how to find it? See here, so you may ask, sir, why you perform the source transformation? So I perform source transformation. So if I want to apply here, this will act as nodal analysis. You have to apply nodal analysis at this point and this point, and we'll be having two unknowns. We'll get two equations, and from these two equations, you have to find V1 and V2. So now what we have done, so we removed this unknown. We calculated this unknown as how much voltage? 4 volts, and now this becomes as a known voltage. So automatically this will act as an one branch. Now let's try to understand the problem. So now you see here, already I told the current flows mark this as higher potential. Current flows from high potential to low potential. This is the current in this branch. Mark this current as I1. Mark this unknown current as I2, flowing from high potential to low potential. Mark this current flowing from high potential to low potential, and mark this current as I3. So now we are going to apply Kirchhoff's current law at node V1. So when you apply the node V1, so how many entering currents are there? As per our nodal analysis, there is no entering current, all are leaving currents. 0 is equal to V1. So current is leaving. What is the leaving polarity of the voltage? V1, and current travels in the 2 ohm and it travels here. What is the leaving polarity we have here? Minus 5. V1 minus 5. V high potential minus low potential by R. What is the branch resistance? 2 ohm. Okay, or you can will come best to solve with one more step. So entering currents are 0, leaving currents are I1 plus leaving one more leaving current is I2, and the next current is I3. I have written this I1 here plus I2. How to write down the current I2, the current in this branch? So already I told high potential minus low potential by R. So V1 minus 0 divided by 1. So how to write down the current I3? So current is leaving. What is the leaving polarity of the voltage? V1. Okay, and current is leaving. What is the leaving polarity? How? Minus. Okay, minus how much? Minus 4. Or directly at V1 minus 4 divided by, what are the resistance? 2 plus 2 is how much? 4. So this is like solving the problem. So 0 is equal to V1. V1 you take common, 1 by 2 plus 1 by 4 minus 5 by 2 minus 1. You shift this negative terminals to positive terminal, then you are going to get the V1 as V1 is equal to 2 volts. Now what is the voltage at this point? This is 2 volts. What actually we require? So actually I require is I2. Okay. So what we require is I2. So I2 is equal to V1 minus 0 by 1, this branch. So this is 2 volts minus 0 by 1. This is the I2. Therefore, we are going to get the I2 as 2 amperes. This is what our answer is.